Hello, everybody. My name is Ajay Mungara. I am the Senior Product Manager of Intel IoT Developer Experience. I'm part of the IoT Developer Program team in Software and Services Group at Intel. The topic I'm going to talk about today is to amplify the value of your IoT solution through lifecycle management. So in this session, what you're going to learn is about all the different phases that you go through in an IoT solution deployment, and how Intel tools, technologies, and capabilities that we have for you is going to help accelerate your solution lifecycle. The main topics that we will cover as such would be the overall IoT solution phases. What are the phases that typically we have seen the solutions go through? We will talk about the IoT developer journey. We will talk about some of the challenges that we have seen the solution, right? Sometimes the solution gets stuck at the prototyping phase, never to see the light of the day. And we will talk about some of the challenges and how you could overcome them. And then I will introduce you to the different elements of the Intel IoT Developer Program and how we have designed this program primarily to help you accelerate the solution lifecycle. Now let's talk about this IoT solution phases. Okay, so I'll go right from the top. Typically what we have seen in an IoT solution is every solution goes through these different phases: exploration, prototyping, and implementation. So the phases that we call it as prototype to learn, prototype to productize, deploy, optimize, and develop, right? So the difference between prototype to learn and prototype to productize is that, hey, look, when you're doing a prototype to learn, you're probably doing a weekend project. You're rapidly using capabilities such as a BeagleBone Black, Raspberry Pi, or Arduino type of things, where you're easily able to complete the project in the weekend. You're trying to learn stuff and things like that, right? So you're exploring to see even if your idea actually works, or you're trying to learn the new capabilities or SDKs or new hardware products that's there in the IoT space. But when you do prototype to productize, you need to think about not just about learning. It's not about just kind of smoke and mirrors and things are actually working, but you have a view for how you intend to productize it. You need to make your product or your prototype in such a way that you're able to take it to the field deployment. You're able to get some initial feedback from your customers to see if you're on the right track or not. If you're an entrepreneur, probably you will have to have a prototype which you could visually represent and talk to your venture capitalists about it. Or if you're working in a large company, you would want the prototype to be in a state where you could showcase it to your management and say, hey, here is the idea and here is a prototype. Here is how I would want to take it to product. And here is the investment that I need. Here's the funding that I would need. Here are the resources I would need, right? So you're trying to lay out the groundwork for how you want to take that prototype to market, right? So here you're just laying out the groundwork. And then you move that product to the implementation phase. At the point of implementation is where you have more formal development structure. You will do code coverage. You'll do code audit. You will do you'll make sure that the security and privacy aspects are accounted for, and you're optimizing the solution for deployment. You're figuring out how to optimize your BOM cost, bill of materials, and how the solution will finally get deployed, right? So deploying your product in a limited quantity, 5 or 10 units or even 100 units is different than if you want to implement that for 100,000 units or 1,000,000 units. So the kind of challenges that you will face during deployment will be immense. So you need to really think about those capabilities and tools you're going to use to make your implementation easier. So that is the phases that you see from an IoT solution point of view. But IoT in general, is a perfect combination of hardware, middleware application, and cloud capabilities that come together in an IoT solution. So that's what you would see here on the left side of the of my chart, where you need some aspect of hardware. So you need to worry about something to do with the hardware, the OS, the firmware, and things like that, right? You need to really make your solution better using different APIs through middleware or middleware tools that you might have. You're developing an application or a service that sits on top. Ultimately, I of IoT is internet. So you need to figure out how you're going to leverage the cloud, how you're going to take the data that you have, how you're going to harness that data, how you're going to do data analytics and stuff like that. The reason why you see these boxes in different shapes is because I believe that at least what we have seen in the developer community is during the exploration phase, you really don't want to worry about too much about hardware optimization. You don't want to worry about OS customization, the BIOS customization, and things like that, because all those efforts is a much longer term goal for your solution. Initially, what you're doing is you're just rapidly trying to take your solution and take an off-the-shelf hardware, off-the-shelf OS, and get your product to work, right? And that's your goal during those phases. But you may or may not have a choice when you get to the implementation that you may have to touch the hardware, you may have to optimize the hardware, you have to customize the OS, and you will have to have a full-fledged implementation of your cloud infrastructure. So all of these things are valid reasons why you need to look at these things. Now, with that introduction of the IoT solution phases and what is really involved, now let's go a little more into understanding this IoT solution journey. So in the IoT, understanding this IoT solution journey is the same phases, but it is in a cyclical way, because it's like a cycle, right? It's not like once you deploy your solution, you're done. You need to figure out how you're going to manage that solution, update that solution, what you're going to do with it further, right? So you go through this cycle between a technology, business strategy, and user experience, right? Right at the center of it is oftentimes you could have a technically superior product, but if your user experience suffers, then nobody's going to use your product. Or you could have like a really usable product and it has technologically superior, but if you don't have a business strategy, or if you don't know, if you're not solving the right problem, or if nobody's willing to pay for it, or if your customers are not adopting your solution, then there is no point. So that's why when you're thinking about a solution, think about how the convergence of technology, user experience, and your business strategy comes together. And in an IoT solution, you would have various types of developers will come together, and we will talk a little more about the type of developers who will you may have to involve in this case. And there is a development journey and there is a management journey, right? Once your solution is deployed, you need to find a way to manage that solution. If you cannot effectively manage your IoT solution, and if you're not thinking through how I'm going to manage the solution, then the solution is incomplete. Now, I did talk about a little bit about the people that will be involved to bring together an IoT solution, right? It is, you have device, hardware, OS type developers, because you need to understand a little bit about the hardware. Not in all cases, but in most cases, you will have to figure out how you're going to optimize at the device level, how you're going to take out the best performance from your device, from your firmware, from your customized OS, making sure that you have the right kernels and all of that, right? So you need to have somebody or a team of people who are looking at it from the device side. There are people you would need what we are calling it as application developers who are trying to build the actual use case, right? They're deploying that use case. They're figuring out how they can bring together the different services, APIs, and all of it together so that your customers will have the right experience. So those are the application developers. And then there are the solution developers, right? These could be system integrators, solution developers who are stitching together that entire solution, because they are responsible for scaling your solution. They're responsible for making sure it gets deployed, it gets managed well, it gets optimized well. It is getting like the various parts of the solution are coming together so that the customer will see the benefit of the overall solution, but not some part of the big picture, right? So that's their responsibility. So you're going through this journey by requirement gathering, by building a solution, by optimizing, and then delivering what is needed from the market standpoint. So typically in an IoT solution journey, you have the people from these various skill sets come together. And this is just a representation skill sets. But like, for example, application developers could also be mobile developers, because you might have a mobile component to your IoT solution. Like, for example, you want to manage your factory floor with an iPad or with your phone, or you want to be able to check your analytics get some alerts of what's going on in your factory as a text message. So whatever those could be, you would need those type of application use cases integrated into your solution. Further, what it is important in this slide for you to take away is the goal of understanding this IoT solution journey is to understand what should be your focus at what phase of the project, right? Oftentimes, people say, hey, look, you need to start thinking about deployment, and you need to start thinking about optimization right at the beginning, which is okay, because I've seen projects being very successful by doing that. But it will be a long journey, right? Because you will spend about like a good 6 months to a year, even just documenting your product requirements. Or you will spend a lot of time trying to think about some aspects that might be only applicable during the optimization phase. So what you need to understand is, when you're doing prototype to learn, the goal is to look at a very simple setup, get all the tools that's out there, use the platforms that's out there, and figure out how you can rapidly get your concept figured out. All right. And when you're doing the prototype, the prototype should be good enough so that you should be representative of the use case that you're trying to build. But then it needs to have a path to transition to a product and scale. Because oftentimes I have seen customers where they start the prototype, they abandon that prototype, and then they start fresh and say, now the project is sanctioned, now let's go develop and optimize. Some of the challenges that management frustration is, they say, hey, look, this team came up and they showed me this demo. They spent like 4 weeks doing this. And now they're telling me that to take that prototype to product, it's going to take 2 years. And I can't believe it, right? So, but oftentimes that could be true, because when you're doing a prototype, you're not thinking through a lot of these different scalability aspects. And to do it right, it might take that long of a time. That's okay. But overall, trying to make sure that your management, trying to make sure that your customers and everybody understand that from a demo to actually taking it to a product, it is a life cycle and it takes time. And you will be expected over time to cut short that cycle, because you do a demo and then automatically people will assume that the work is done and now they can go talk to their customers and sell it, right? So the challenges that we have seen is, on the technical side, you need to worry about security and trust, the interoperability, because you have amalgamation of various technologies that's going to come together in your IoT solution. You need to figure out the integration of an OT and IT, because you need to worry about how the operational aspects and how the IT or the enterprise aspects are going to come together, and how they integrate and work in your IoT solution space. And analytics, right? Because IoT solutions typically generate a whole bunch of data. And what do you really do with all of that data? What do you do in terms of analytics? What do you do, because if you don't plan it well, then you're going to have bandwidth problems. Your cost will be really high. You need to figure out where you're going to do the analytics, right? You're going to do it at the edge. You're going to take all of that data, push it into the cloud. So there is all these decisions you have to make from a technical perspective, and they're not simple decisions if your data that it gets generated is in large quantities. From the business standpoint, you are worried about, how do I scale the solution? How do I sell it in more units? How do I make the solution available in a different geography, and worry about those unique certifications that might be applicable to those geographies? you're worried about the cost and the ROI, and what are some of your challenges with respect to the bill of materials and things like that. And from the business side, you're also worried with the security and privacy, obviously. And from a business side, I have seen this when I talk to some of the CTOs and business leaders. They tell that, like, from every business group comes with ideas, and how do you prioritize all of it? And even if they get all of these solutions, then how do they integrate all of these pointed, fragmented solutions into a big IoT strategy for the company? All of these are challenges that you need to look at. But let's now narrow down the focus from a developer standpoint, right? From a developer standpoint, I completely empathize with your challenges, right? There is rapidly changing technology landscape. Every day you hear about some new technology that's coming up. The learning curve, or the expectations from your management to learn new technology very quickly is becoming a norm. And then convergence of all these different technologies, right? The cloud technology, the edge technology, the protocols and communication, connectivity, all of these things are converging. So how do you kind of stay current with all of that? And then technical compatibility. And so basically, like, the expectation is you develop something and that's going to be there in the market for 12, 15 years. And how do you make sure that the technology is compatible and in the long term? And there's all these evolving standards that you need to look at as well. So from my point of view, the way I see it is, don't learn from a technical perspective. So don't say, hey, look, I'm going to go learn this technology. That usually works. But the best way to learn a technology is to think about a business use case in mind, right? Even it could mean that you're spending a weekend project. Think about how you're going to figure out how do you automate your lawn sprinkler system, or how do you do something with your garage door opener, or something like that, right? So whatever it might be, have like a use case in mind, have a result in mind when you're learning something. And start with a simple one and then evolve that use case, right? It does not mean that you have to have a very complicated use case where you're going to do something with a satellite generated data or whatever. So you need to start with a simple use case with a simple set of sensors, take that data, and then figure out how you're going to evolve that use case. And again, oftentimes I get this question, and even in this forum, we got quite a bit of questions of where do I start? And is the skills that I have today, is it applicable in IoT? The good news in the IoT world is whether you are a mobile developer, a web developer, embedded developer, a data or a cloud developer, or AI, machine learning, whatever might be your expertise, that expertise is applicable in the IoT area. Because I've seen some very, very good IoT projects implemented by the traditional embedded hardware developers to the cloud developers who have taken the data and have done some beautiful applications and made some meaningful difference in the business strategy for the company. Overall, think about the development journey. Don't think that, don't set the right expectations is my point, right? Make sure that your management understands that the whole IoT solution is a journey, and it goes from a simple prototype to all the way to a production deployment. And you have to tackle different things at different phases of this project. And deliver quick wins, because if you're saying that, hey, look, let me start and document the requirements and it's going to take 8 months, and the first results you're going to start seeing in the year 3 is not going to fly, because the expectation now is to really start seeing some benefits very quickly. So figure out how you could divide the project into multiple small quick wins. And everything goes through that simple solution journey of prototype and deployment, right? So conceptually, you can think of IoT as 3 parts. One is things. Things are the edge devices, right? Things could be simple sensors. Things could be like more advanced sensors or like devices where a lot of processing happens on those devices. Think about a camera. Nowadays, a lot of these cameras, video cameras, do a lot of things at the edge, right? I mean, because they don't want to transmit every piece of data to the network, what they would do is they will do a lot of AI and intelligence at the edge. So only those events that you would want to see will be transmitted to the network. So there are things, and there is network. Network is where you would determine to process some kind of a compute so that you're not sending the data too far into the cloud because of your bandwidth constraints, because of your latency constraints, because of the decisions that you need to make immediately, right? So there is a network part, and then there is a cloud part. And the cloud part is where you're trying to take the data, take meaningful insights out of the data that gets generated, and use those insights back into your solution to drive better business insights or get your use case or improve your use case, right? Now, with that background, now let's talk about how Intel is helping accelerate your IoT development cycle, right? There is, again, not one thing that we are doing, but it's a collection of things. So I want you to look at the big picture, because that's why we combine all of that into an umbrella, which we are calling it as Intel IoT Developer Program. And in that program, we'll give you dev kits, sensor and connectivity APIs, the developer tools, the various SDKs and APIs from a middleware perspective, the cloud connectors that enables you to take the data easily to different cloud systems out there. We also have a lot of code samples and reference implementations, so that way you don't have to start from scratch, or your learning experience can be simple, because by starting with a code sample or a reference implementation, really what happens is you're able to cut short your life cycle, at least from that point of view. And then we will combine all of that and show you what we are doing here, because every one of these things that you're talking about, whether it is APIs or developer kits, we are thinking about the solution lifecycle. We are thinking about, like, we know that you're going through that journey, so we are trying to offer solutions that's mostly tackles or helps you at that part of the journey, right? So now let's talk about the different elements from a program perspective. We have the dev kits, we have tools and resources, and we have this developer zone, which is software.intel.com/IoT. That is a home of all of the things that we bring together. And then there is education and workshops that we conduct, where this is one of examples of it, where we are doing this webinar series to help you understand the different technology offerings from Intel. And we are getting one of the key things of this workshops and these webinars is we are bringing not only just the Intel point of view, but we are bringing a lot of external speakers so that you get like an industry point of view of where things are with this as well. And then we also have these partner programs where we know that IoT solution is not just one company coming together and saying, hey, here is your solution. We are partnering with a lot of industry partners to bring together an end-to-end solution for you, so that Intel with a Google Cloud works really well, right? So we need to make sure that you make that happen. And that's why this program partners are important for us, and we will walk you through what we are doing in that space. So from an IoT developer kit standpoint, right, we think about this as the kit is everything you need from a hardware, software, and tool standpoint for you to quickly get started. We know we have had developers who come to me and say, hey, look, I buy this board and it doesn't come with a cable, it doesn't come with a power supply, I need to buy that separately, and it doesn't come with the sensors. Even for me to get started with a simple project, it takes me multiple weeks before I can get going on it, right? So what we typically do is we assemble all the things that you as a developer might need to get going on your effort. And that's what we call is these developer kits. And they're not just one kit. I'm just giving you this as an example. And we are working on assembling a whole bunch of kits, right? So we will have also targeted kits. For example, we would have like an agriculture kit, or it could be a vision kit, or we are trying to bring kits which are closer and closer to the use case that you would want to implement, right? We also have generic kits. And these generic kits are a good starting point if you don't have like a particular use case in mind. But if you have a use case in mind, whether it's a smart home or a speech use case, or if you have a smart building use case, we're trying to bring together kits that help you get closer to your use case in terms of implementation. But once you do like a simple prototype with these kits, then you need to do quickly, you need to take it up to do a field test where you can buy some shells or enclosures where you can put together your prototype and do a limited field test. I strongly encourage you do it, because we have found instances in which every time we have done a field test, we have learned something that we didn't know before. I'll give you an example. There was an agriculture project that we did with one big company where we put some sensors in some paddy fields and corn fields and whatever. And then we realized that when the tilling machines came around and like they took away all the sensors that we had in the ground, and we came back the next day and we saw, why is it not getting any results? And it turns out that the sensors we expected to be in a geofencing location X turned out to be somewhere else, because they were all over the place in the field. So when you do the field testing, you'll start to recognize some of the challenges on the ground and what you need to do to address them during your deployment phases. And then you need to worry about depopulation, BIOS customization, and manufacturing that product in volume. So most or almost all developer kits that we are working on, we are bringing together the industry partners. Like in this case, we got Aon, which is doing the Subsquare board. We got Seed. We've got Ubuntu Canonical that's doing the OS customization. We are also bringing together other service providers who do BIOS customization, etc. So at the end of the day, when you're thinking of doing a prototype using this kit, then we will give you a clear path on how you can take that kit and take it to mass production. You can see in this Subsquare kit, we have the hardware board, which is an Subsquare Apollo Lake based board. And then you have the OS, which is an Ubuntu 1604 server that's preloaded. We also have an option for Ubi Linux and Yocto and Wind River Linuxes as well. And then we have the tools, which we will talk about it in a minute, like the Arduino Create and Intel System Studio, etc. We will talk about what those tools can do for you. And a bunch of sensors so that you can actually start implementing some simple prototypes rather quickly. So you buy that box and you get everything you need. And it's not just about prototype, right? If we had to stop at prototype, then it was different. We are always thinking about how can this kit and whatever the work you do with this using this kit, how can it be beneficial and how can it cut short the life cycle for you to take the solution or your prototype and move it quickly into a development phase and further move it into a deployment phase. So think about this kit as a start of your journey. And we are here to hold your hand all through that journey with tools, capabilities, and other offerings from Intel. Because at the end of the day, kits or simple prototypes is good, but it's not what most customers have asked our help from. They want solutions that can be actually deployed at scale in the market. And Intel is here to support you through that journey. Let's now talk about sensors, right? Sensors, again, can be from a simple maker type, cheap $2, $3 sensors to a very complicated, advanced sensors, which can cost thousands of dollars. But oftentimes, you could have a simple use case. My favorite example is a temperature use case where you can buy like a $2, $3, you can buy a temperature sensor, and it will give you a temperature. It may not be all that accurate, and the temperature sensor won't be. You won't be able to put that temperature sensor inside like a furnace, and the range of the temperature that it will be able to read might be limited. But for the prototype purpose, it's good enough to show that, hey, look, I'm reading the temperature, and based on the temperature range, I'm reacting in some way. I'm like sounding an alarm, or I'm starting another machine, or starting another process. Whatever, right? So you are able to show that by using this sensor, I'm able to trigger something, some action, some result, right? That's a start. But when you are thinking about deployment, you need to figure out how am I going to use a production grade sensor? How am I going to improve that accuracy of that sensor? What's the long life for it? Is the data is like, you need to make sure that the sensor is the right sensor when you're deploying it at scale. So what we have done is we have worked with a lot of industry partners here again, from sensor providers who give us maker type sensors to large industrial scale sensor providers from STMicro to Honeywell and Bosch and others. So we want to make the journey easy from an API standpoint. You can start with a simple sensor. You could get your use case as far as you can get. You can show the demo. You can get people excited about your idea. And once you're ready to go to production, you can transition to more connectivity sites type of sensors or industrial grade sensors. So UPM is a sensor framework that we have that allows you to go through that journey. We support a large catalog of sensors today, and it is increasing by the day. It's a completely an open source project where you'll be able to get all these sensors. We support multiple programming languages for these sensors. And every sensor comes with a code sample, so you know how to use that sensor, how to get started with it, etc. So we are trying to say that, hey, look, you start here and you would go through a journey of connectivity and industrial protocols as you go through this thing. And there are some sessions in this webinar series where there is more in-depth topics which talk about these sensor libraries in particular. As I said, we also have this open source hardware abstraction layer, which we call as Umbra. And this Umbra handles pin muxing and memory allocations, and it does a lot of different things. So what really it is if you want to do a standard C++ code on a hardware, it's a lot of lines of code, and you need to do a lot of steps. We have created an abstraction library that allows you to cut short all of that process, so you could simply use this raw library, and you are able to easily program to any boards. And what MRA also brings you is it also helps you to move from one hardware to the other, because we have a wide range of supported hardware. And you can start with Atom product, and then once your computing needs evolve, you could go to Core. And if you think even you need more compute, then you can go to Xeon, or in case if you want to use some acceleration, you could. So literally your programming model is more or less remains the same, and you would be able to transition as your computing needs evolve. Now, from a developer tool standpoint, what we did is we worked very closely with Arduino, and we bought the Intel-based platform support to the Arduino Create platform. And we integrated it in such a way that it's very easy for you to use the Create platform to get started on any Intel-based platform. And you build your prototype, or you build your use case. As far as you want, you can use the Arduino Create. But at some point where you really need the performance capabilities, you need the debug, trace, and profile type functionality, we provide a mechanism for you to transition your project from Arduino into Intel System Studio. It's a product that helps you analyze, build, and optimize, and debug and trace type functionality, which you will need at some point or the other when you're thinking about scaling your solution, when you're thinking about deploying your solution. So we wanted to make sure there is a very clean path from Arduino Create environment to the Intel System Studio, and we made sure that happened. So you could enjoy the benefits of a simplicity and ease of use what Arduino brings, and to kind of get through your journey as far as you'd want to go. And then when the time is right, you could use the power of Intel System Studio to optimize your solution to take it to market. So what did we do with Arduino Create? That's a question that I get quite a bit. And what we did is we added key capabilities that centered around the Intel architecture. Really what it is it's an easy getting started experience on any of our developer kits that we have, from Atom, Core, Xeon-based developer kits. You could use it with this platform. You'll be able to get started by setting up an Ubuntu or a Yocto Linux, and we are also going to support WinRiver Pulsar. And in some instances, for some kits, we already support Pulsar. So you'll be able to install the OS, and it will have all of the components that you need to get started. Then you will be able to connect to that abstraction layer we just talked about, the Umbra. And so that way you will be able to code immediately using it. And the sensor libraries that we talked about is also integrated. And we also integrated a whole bunch of other Intel libraries and SDKs, which we will talk about as well. Then you'll be able to connect to multiple cloud services from Amazon, Microsoft, and others, so that you are able to easily take your data and push it to the cloud and do some compute there. And the export and the bridge, we talked about it. So that's what the Create does for you. And there is some sessions in this webinar series where you will learn more in depth about the Arduino Create and what we have done there. Some of the SDKs that we have from vision-related SDKs, including the Media SDK, the Graphic Performance Analyzers, OpenCL SDK, the Context SDK, all of this are in the media space. We have a lot of AI SDKs with the deep learning deployment tool, deep learning algorithms, etc. We have a lot of security APIs that we are working on, and some of the APIs which are public out there, like Intel Secure Device Onboard, that helps you to quickly provision. And if you think about implementing these APIs right at the beginning, it will help you when you are thinking about scaling and deploying your solution in the long run. So the SDKs and the APIs that we have is really going to help you with your IoT solution. And each of those APIs are designed in such a way that you can get started quickly in your prototype phase, where you don't have to worry about all of the underlying complexity. You could perhaps use some abstractions. And as your solution evolves, you'll be able to get through more abstractions. We work with a lot of industry partners, and like Amazon, Google, and Microsoft, where we have made sure that the connection to those cloud environments is easy. So we have created a lot of seamless experience. We have created code samples. We have created documentation that allows you to take your solution and rapidly connect to any of these cloud providers. So that way you will be able to take your data into the cloud and use their tools to do a lot of analytics and take the insights and drive and improve your IoT solution. And FPGAs acceleration is the other thing, where we, as you know, we have Altera, we have Movidius, we have a lot of these acceleration capabilities through FPGA and other accelerations. So essentially, it helps you with as your compute needs evolve. You want to expand your I/O, or you want to boost your performance, or you want to do this dynamic acceleration. You will be able to do all of that using these acceleration capabilities. So we offer you these things, so that way you would be able to dynamically assign workloads to these FPGAs. So that way, at a cost-effective way, you will be able to scale your solution as your compute needs evolve. So we are integrating a lot of these FPGA type capabilities and tools and SDKs into what we offer. So that way it is easier for you to use these capabilities as your solution evolves, or as your use case demands. Developers love code. We know that. So what we have done is we have taken all of the things that we just talked about, from dev kits to SDKs to tools and to FPGAs and all of that, and we created a whole bunch of code samples. They might be simple code samples from access control, alarm clocks, and that and this, but at least by following and doing some of these code samples, what will happen is you will get comfortable with the technology, you will get comfortable using the APIs, and you're like, okay, I know what I'm doing. I'm ready to get started. I'm ready to go. You will learn as your step-by-step instructions, right? We have documented everything. So that way what happens is you could be able to, and all of the code is available in GitHub, so you can pretty much cut and paste the code into your into your IDE. And in fact, we have integrated these code samples into Arduino Create, and we are integrating it into Intel System Studio. So with one click of a button, you'll be able to have the code sample up and running. The next is the reference implementations. So we have taken this reference implementation one step further. What happens is a code sample is something that you perhaps can do it in an hour or two to get going, learn it, and quickly assemble something, and you have something working. In case of a reference implementation, one of the feedback that we got when we did the code samples was, hey, code samples are too simple, but my use case has a mobile application, has a web application, has a device thing, has a something more optimized, and this and that and all that, right? So what we did is we took some use cases and we did a complete reference implementation, right? We targeted like smart home, smart transportation, camera use cases, vending machines, and that all kinds of things, right? So we are adding more and more of these reference implementations. And what these reference implementations are, it will have a complete documented end-to-end use case. Oftentimes, this is a use case which we have seen in the real customers and real deployment. What in this case is obviously we won't share any customer IP or other things, intellectual property. We are responsible for protecting it. What we do is we learn about what that use case is, and at a high level, right? Like a vending machine is a typical use case. And what we do is we take that use case, we document like the complete business requirements around what needs to be done. Then we start by doing we do the complete journey for you. We will do the prototype phase, and we'll do a development phase. We'll do the optimization phase. We will do a mobile application surrounding it, and we will transition from using a simple maker sensor to like an industrial grade robust sensor, and we'll show you how all that is done. And we have the complete code out there in the Git repository so that you will be able to replicate that entire experience for you. And obviously, this takes a couple of days for you to be able to replicate this entire reference implementation, but that's the intent, right? The intent with this reference implementations are that we are looking at a real potential business use case that these products are targeted for, and we are doing the complete implementation and the journey for you. And all of this is completely open source code that you can just take it from the Git repo and use it for your own purpose. So the reason why we are doing these code samples and the reference implementations is because this is the direct feedback from what we have heard from the developer community about what they would like to see us do. Because IoT, I agree, is an amalgamation of a lot of technologies. There's a lot of hardware choices. There's a lot of protocols, a lot of sensors. There is a lot of SDKs. There's a lot of things, right? So we are doing this use case oriented reference implementation approach, so that way we can stitch all of these various concepts that I walked you through right today, from dev kits to SDKs, to the development tools from Arduino to Intel System Studio, to all of the different libraries that we have out there. All of it, we are bringing it all together in these reference implementations so that you understand how all of these different pieces fit together in your IoT solution journey. We are in fact taking some of this in further, where we are going as far as the field deployment. We are going as far as trying to figure out how we can scale it and mass produce it. So that way we take all of that learnings and share it with the community here, so that you don't have to go through some of the hiccups we do, right? So for example, the first reference implementation we built took us like 2 quarters to even get to a point where we are happy about it. But over time, we have got better and better at it, and we are doing it in shorter and shorter cycles. So all of the learnings we do from one reference implementation, we carry it to the next one. We have a lot of training material on the website and the documentation, and we have tried our best to categorize this documentation at different phases of this solution lifecycle, from defining and evaluation and learning and deployment and management and optimization and things like that. And here's just a sample set of documents that we produce. So we produce a lot of content, and this content, and we have tried to categorize and align the content with that solution lifecycle, so that you're looking into the right piece of content depending on where you are in your solution lifecycle journey. So again, right, this is talking to industrial customers, talking to big, from NASA to Lockheed Martin, to imagine, I'm not talking about a simple entrepreneurs, right? I mean, simple solution to prototype. All modern development paradigm nowadays invariably starts with rapid prototyping and exploration. So we have device manufacturers, system integrators, end users, application developers, all coming together inside its IoT solution development. So we are providing you with tools, software, kits, the education through content, support, and community in recognition of that life cycle. And we are making sure that you have what you need to accelerate that life cycle. And again, summarizing it, we recognize this developer journey. We recognize that you're going through these phases. And I strongly encourage, if you're not already thinking about going through these phases, I encourage you to do so, because the most successful projects that I have seen implemented in the market are those companies that have rapidly accelerated, and they've done really good field testing. They've done projects with addresses real customer problem, and they're taking customer input all through that life cycle, and they're able to do that by cutting short their journey over time. So, and again, don't forget the technology, developer experience, and your business strategy all needs to come together for your final IoT solution. With that said, let me switch to see if there are any questions that I can go to. Oh, do we have any examples on advanced sensors? Oh, yes, we have a lot of examples on the advanced sensors. So I will send you the if you could just search on UPM website. In fact, there is a link. I believe it's upm.mra.org. You can just go to that website. I will send you that link, where you have you can search on the industrial grade sensors, and you will find sensors from Bosch, you'll find sensors from Honeywell, you'll find sensors from ST Micro. We are working with these industry partners to support more and more of these sensors, because the sensors, you'll have thousands and thousands of sensors out there. And some of the challenges that developers have is, hey, look, I have these $2-3 type sensors, but there's also like $2,000 sensors. Now, how do I take the sensors, my prototype that I've built using the simple sensors, and transition into an industrial grade sensor? All of this is possible, and we have shown examples on how you can actually do it. And this industrial grade sensors often comes with some proprietary drivers. They come with some proprietary optimizations and all of it. But we do our best to standardize it in such a way that the APIs that you use and the programmability that you use is easily transitioned that way. Okay, and I'm hoping that this session was very helpful to you. And I'm always available on LinkedIn, and I'm available on the Intel community. So feel free to send me any questions you might have, and I'll be very happy to address it. The reason why I like this session is because I have worked with a lot of customers in their IoT solution journey, and I have seen this journey over and over and over again. And we are trying to structure our program and capabilities in such a way that it is beneficial for you to accelerate your solution lifecycle. So thank you very much, and really appreciate your time. Bye-bye.